the Sustainability Management Master's Program, you're answering one simple question. Do you care about your future generation? If you care about your kids, their grandkids, then you care about sustainability. And a sustainability manager is someone who has the tools to make people understand how they can contribute towards developing a sustainable world. We have both part-time and full-time students. Our curriculum is 30 hours. Instead of thesis, we have a research project course and a seminar course which provides them with the kind of research background they will need to be successful in their job. But at the same time, sustainability is not always everything about environment. It also relates to the business. They will take a sustainable business strategies course. They will take a project management course. Most of these courses are going to be taught by industry people, the people who are doing sustainability on a daily basis as a part of their job. Any organization that has a large number of employees and has a physical infrastructure, they will have to have a sustainability office. If you have the passion to develop and maintain a sustainable world, come to us and we will help you shape your passion into a career which will create an impact.
The Stevens Institute of Technology is proud to present the Hugo New Corporation Sustainability Seminar Series, brought to you by Brown & Codwell, Geocentric Consultants, H2M Architect and Engineers, BEM Systems, Catalyst Group, and WSP.
Thank you very much, Tibbs, and it's my pleasure to be here and on behalf of Beatcone and the company I'm with, Montrose Environmental. So thank you very much. And a special note here for the sponsors. Thank you. Thank them for sponsoring this event and helping to make it all happen. So again, to recognize the sponsors. And of course, there we go. So I'm going to talk today on due diligence, emerging contaminants, specifically on PFAS and brownfield redevelopment, and can they coexist? So redevelopment, pretty straightforward. You have a property that was already used and now you're going to improve it. So that's pretty straightforward. You're permitting things. But so now you come to a brownfield redevelopment. And so just to review, I'm sure everybody here probably knows, but what is, a brownfield? And it's a property, the expansion, redevelopment, or reuse of which may be complicated by the presence of potential hazardous substances, pollutant, or contaminant. So take note that it only has to have the potential. It doesn't actually have to have those. So that is the definition of brownfield. EPA estimates there's over 450,000 brownfield sites in the United States. And why do we investigate, or why are we interested, and Beacone interested in redeveloping? It's to clean up, reinvest in these properties, which increase local tax bases, facilities, job growth, utilizes existing infrastructure, takes development pressure off of undeveloped or open land, and both improves and protects the environment. So that's what we're looking for. But now we end up with emerging contaminants, PFAS, and we start getting all tied up into a knot. And the question is, do we really have to? So tonight I'm going to try to go through these objectives that are here. Is a little bit about the PFAS and the chemical complexities, the remediation challenges. We're going to look a little bit at federal and state regulatory uncertainties, federal, state, and commercial liability protections, some sampling and investigative challenges, a little bit on PFAS trends and reporting, and lastly on professional judgment. So PFAS has many great usages. We use it in all these different products. They all work extremely well. And so the question is, what's all the fuss? Well, the fuss is that they weren't made to get released into the environment. And when they were first made, and they're now referred to as well as forever compounds, and that is because they basically want to try to last forever. So all these ones that are sources below are a lot of ways that these chemicals now have entered and or are entering into the environment. And we call PFAS and these emerging contaminants, but they're only emerging to us because we are now starting to find them in the environment, not the fact that they are new. They have been used worldwide for over 80 years now. So real quick chemistry lesson here. We have per and polyfluorinated alkyl substances. That's what PFAS stands for. The two compounds on the left are perfluorinated, and they're the two most studied and the most sort of famous right now, recognized. And the first one is the PFOA, and the one below that is PFOS. So the difference between those two is that they have a different head on top of them. One is a carboxyl acid head, and the other one is a sulfonate head to it. But the main ingredients is carbon with fluorine attached to them. A perfluorinated compound has fluorines attached to all of the carbons. Off to the right is a polyfluorinated compound, a fluorotelmer, and that's a 6,2, and the difference there is the last two carbons moving to the right do not have fluorine attached to them. And for the PFOA and PFOS, we have 8 carbons there, which we consider to be long chain, where we have other PFAS compounds that have less chains than that, 4, 5, 6, and they go well up past 8, up to 12. And with those, the stronger the bonds, the harder it is to break them. And that is what makes them want to last. So a couple of specific challenges for PFAS remediation. First of all, they could have multiple ionic states. Any one of those three, anionic, cationic, or zwitterionic. Okay. They also can be sulfonates or carboxylates. They also can be linear or branch, which means that linear is straight across, a branch is they're folded in among themselves. They would have the same molecular weight, the same compounds in it, in the number, but they actually react slightly different from linear and branched. And in case I forget to tell you later, when you're looking at analytical, you want to make sure that the lab is reporting at least the combination of the linear and branched, not just the linear. However, our standards that we apply to are in fact only linear. So chemical and physical properties, they have all those different types of properties. We have anywhere from 5,000 to some people say 8,000 PFAS compounds. So this is why they're so difficult, because each individual PFAS compound has different properties. And they're not linked together like PCBs all have the same basic physical properties. Dioxins, very much the same, but these are not. So a couple things to remember is they don't like the chemical biological transform, except for we can degrade fluorotelmers, but when we do that, we turn them into stable compounds. So basically, though, PFAS are not volatile, but we will find them in the air. They don't adhere to soil and sediments very much, but we will find them in there. And for the most part, they love to be in water. So the exposure routes, right? Ingestion, number one. Right? A couple of things to note, these compounds have been found in all 7 continents. So these haven't been used in all 7 continents, or at least not regularly. So how do they all get there? And blood serum, 98% of humans have it in our blood. but EPA only associates how we got that 20% from our drinking water. So 80% is coming from ingestion. So your pizza boxes, your drinking water, what you breathe in the air, those are all ways that it gets inside of us. So what? What's important then to brownfield developers? What is the most important thing a brownfield developer wants? Liability protection. They want to make sure when they clean up a site, they turn it over to somebody else, that they can walk away and not be able to have somebody come after them and sue them for damages, for health reasons, for future cleanup and everything else. So in reality, there's like 4 main liability protections that I talk about. The first one is federal under the CERCLA program, the CERCLA program being the Superfund. Then you have state brownfield programs, and every one of those programs provide some form of liability if you follow their program. You can get liability protection from commercial pollution, limited liability policies, and you can get them from indemnification. So indemnification is, let's say it's a major company and you take the property from them and they have a lot more resources and things than you have. They could indemnify a developer for that. So just briefly, what are all the federal and state sort of uncertainties that brownfield developers have to face with PFAS? We don't have current federal MCLs, but new legislation is being proposed all the time. Over 50% of our states have adopted or proposed their own standards for soil, groundwater, or surface waters. This makes it very difficult. Toxicity release inventory just came out this year, July 1st, 2021, which was the reporting for the year 2020. And that's the first time manufacturers had to discuss and identify whether or not they were using any PFAS compounds, up to 172 different ones. There's also the advance notice proposed rulemaking for PFAS manufacturers and formulators, that they have to do increased reporting to the public. And with that is going to come more scrutiny as far as what they may be discharging from their facilities, knowingly or most likely unknowingly. We have the 5th unregulated contaminant monitoring rule that will be coming out. This is for public water supplies, and they have to, every 3 years, this new set of standards, list of compounds come out of unregulated compounds that they have to look at. So the UCMR 3 that was out a while back is the one that first picked up these PFAS compounds. 6 PFAS compounds were part of that to be investigated, and that really was one of the things that brought out where we are and all the emphasis going forward. There's new toxicity reports coming out all the time for PFAS. We also have a number of different methods for analytical, and I'll talk about those. EPA came out with a guidance document, Disposal of PFAS Materials and Substances, which basically in a nutshell said you can landfill it or you can incinerate it. However, if you landfill it, there's a good chance there's going to be leachate issues. And if you incinerate it, we're not sure whether or not you're actually incinerating it enough, and you could be releasing it out in your stack, which is, of course, probably why we have it in all 6 continents. There's continued increased research for agriculture, analytical, research development, toxicity, and expanding enforcement is growing. So under the CERCLA liability, you need to follow an ASTM standard 1527.13. And that gives you, for bona fide prospective purchases, whether you purchase a property knowing it has historical on site, or innocent landowners is under this. If you purchase a property without knowledge that there was contamination, but it's later found, For a contiguous property owners, whether or not you knowledge or not of contamination on site emanating solely from an adjacent property, but contaminations later identified. However, CERCLA deals with hazardous substances. PFAS is not listed yet as a hazardous substance, so technically it's exempt from ASTM 1527-13. So if PFAS not CERCLA, hazardous substance or a priority pollutant, then it's not what's called a recognized environmental condition, and therefore it's not included in your phase one. Well, the question is if you have evidence or if you look deep enough, should you be looking then at PFAS? And some look at the petroleum products section of the ASTM that basically says that petroleum products were included in this scope of work under ASTM because they were used historically widely at commercial properties, and there was other federal or state laws may impose liability for releases or spills of petroleum products. So under that framework, and especially with states coming up with their own standards, that could really put you into having to look or should look for PFAS. So when might PFAS be a wreck? If it's obvious, for example, you're an Air Force training facility, good commercial or customary practice. You've looked into it and the facility used to use materials that you either know had that or suspected of having, or it's been released to the environment and it's not in a de minimis quantity, or it's regulated by the state or the feds. So with your state standards, almost all the states that have standards, and if you're in the Brownfields program, you will now be required to have to look for it. So under the federal CERCLA liability protection, we're looking to conduct all appropriate inquiries. We must state disposal of emerging contaminant substances occurred prior to the acquisition and no potential responsible party affiliation with that purchaser. And the purchaser has to satisfy ongoing due diligence, maintenance, and obligations. So they cannot add to the contamination or worsen it. So if you know that there was contamination out there and you redevelop it in some certain way that now that material, that contamination actually migrates, you would not be protected under CERCLA under that. So as I mentioned, under the state brownfields programs, liability through most of the brownfield programs, and actually I would say all of them have a component for brownfield program for liability release. You have to know then the state that you're in for the brownfield. So if you're in New York, if you are in New Jersey, you have to look for emerging contaminants. They wrote it in for the brownfields requirements for New York State. In New Jersey, I'll get to in a minute of where that applies. There are sampling requirements then. Some states just tell you have to sample. Some, like New York State, actually provided real guidance to it, as well as New Jersey. There's state regulatory standards in those states, and then investigative and reporting requirements for all those. So in New Jersey, you have the Brownfield and Contaminated Site Remediation Act. That's shown here. And basically, for that, we need a provision for releasing the person who undertook the remediation from all civil liability to the state to perform any additional remediation, to pay compensation for damage to or loss of natural resources. That's the protection one can get from the state of New Jersey when you go through the actual brownfields program. So in New Jersey, though, the phase 1 ESA does not meet the standard for the brownfields program, and you must do what's called a preliminary assessment. So here's briefly a couple of the bullet things that differentiate the phase 1 from a preliminary assessment. But basically, in the preliminary assessment, we are really now looking for areas of concern, not just recognized environmental conditions. It also, a preliminary assessment required review of previous remediation and example order of magnitude evaluation. So if a standard changed by more than a magnitude of 10, you'd have to evaluate that. As new standards come for new compounds, you would have to go and evaluate those. Those are things that you would not necessarily have to do with a phase one. PA, preliminary assessment, does not expire. A phase one does, but like any other document, it has a snapshot in time. But the preliminary assessment takes you up through the very beginning, the first time any redevelopment took place or development took place on a site, up through the time that that preliminary assessment was performed. So in the brownfields, remediation of discharge hazardous substance requirements, that you need to have a licensed site remediation professional. So there's about 700 of us in the state of New Jersey, which I am one of them. And as an LSRP, we basically do the New Jersey Department of Environmental Protection's work. And the Department of Protection agency monitors us. And when I'm filling out my documents and submitting things online, an LSRP must evaluate emerging contaminants such as PFAS, 1,4-dioxane, 1,2,3-TCP, and a host of other things. So it's written in here, and therefore, for New Jersey, those have to be evaluated, right? Now, evaluated does not necessarily mean you have to sample. Evaluated means that you have to do exactly that. You have to evaluate the likelihood that it's there and make a determination if you have to sample. New York State is slightly different. If you're doing an investigation and you're looking for what they call TCL and TAL, your whole list of contaminants, you now have to look for PFAS and 1,4-dioxane during those investigations. So switching over, the third type of liability is commercial insurance indemnification. So other commercial protections, insurance coverage, unknowns, they can cover regulatory changes, pollution liability, remediation coverage. You have to understand that these policies all have the same name, but each policy is completely unique. Most insurances companies and brokers don't advertise that they provide PFAS coverage. But if you, as my one favorite broker tells me, money can buy anything. And so if you keep pressing the issue, they'll give you a price to get that coverage. You have to read the policy. It's individual to look for your actual indemnification language. This is all for the buyer or the seller or both to be able to get policies to protect themselves for unknown risks. So the question comes down to, do we sample or do we not sample? And I did a survey not too long ago with a host of attorneys and insurance brokers and consultants, and they were consistently inconsistent in all of their responses. And here are some of my favorite quotes. And this is from an attorney friend of mine. Oh yeah, you're sampling. They don't care what it is, we're going to look for it. We're not going to make this into a science project. That is one of my other very nice long-term attorney friends. We are sampling if there was a fire. Well, you got to understand, was it a fire that you would use type of AFFF foam on, like a high intensity petroleum, or was it a regular house or fire that they most likely wouldn't use it on? But as we talked about in the very beginning, is there's many different products and ways that PFAS is being used and potentially being released to the environment. We are sampling if there's a military base or fire training facility nearby. My question on that would be, really? If it's there, most likely it's from that base. So if you're sampling on your property, chances are you're going to find it, and then you're going to spend a lot of money and effort to try to then prove that it came from the military base or the training facility nearby. And those facilities would be responsible for it, but you're going to end up having the brownfield deal probably fall through. It is ubiquitous, so I'm sampling. Sort of contradictory at times. If you know you're going to find it, then I don't know why you're sampling to prove you're going to find it, and then you have to justify, is it yours or not, or from the property. If I sample, I'll find it, so I'm not sampling. So those are some of the different responses that I get from those individual industries, and everybody does it a little bit different. So what are our challenges? Industrial site history usage of PFAS. PFAS is very difficult to really know if it was used or not. It was a lot of times not identified as a PFAS or its particular thing. You may see it as a fluorohydrocarbon on an MSDS or an SDS from a long time ago. But a lot of times these compounds weren't identified. Matter of fact, they were basically protective by the chemical companies as compounds that did not need to be identified, and especially because they weren't necessarily in huge quantities. So we have sample location media. So here's a site, and I'd say, okay, well, where would you start sampling to even try to look? What methods? I'll go through that in a minute. Whether or not, and I'm going to talk about mass sourcing of areas and some of the difference in regulatory standards, defense reliable data. Defensible reliable data is very important, especially if you're going to end up in a court situation. And inconsistent changing regulatory environments. So those are all of our difficulties. So one of the things looking at is sampling of rainwater that was taken. And this was actually out in Cleveland, Ohio. Well, actually, it was just done across the nation. And they found levels of 100 to 400 parts per trillion. Well, the EPA safe drinking limit for PFOA and PFOS is 70. In Cleveland, they had concentrations of total PFAS up over 1,000. And in New Jersey, your standards for PFOA, PFOS, and PFNA is 14, 13, and 13 part per trillion. So you can easily see that if you're getting rainfall of 100 to 400 parts per trillion of total PFAS, you could end up with very likely these compounds being above your standard just from rainfall. PFAS and air dispersion. So here is a manufacturing plant in West Virginia and showing as far as Ohio, and drinking water wells up to 20 miles from an industrial source were contaminated with PFOA through air deposition. So here if you're going to sample your site, how far away are you going to look to find out if there is a manufacturing plant and whether or not you were downwind of that? Then therefore, if you find contamination, it could be more likely from them than from something that was used on your site. Similarly, in New Jersey, here is a industrial site plant that uses PFAS, and they are being right now accused of contaminating the wells. And those you'll see a little bit hard to see, but the red dots and the darker purple ones that all have concentrations well above New Jersey's drinking water standards of 14 and 13 for those for PFOA. So just to give you a little bit of idea of how much contamination could travel through the air, if I had 1 liter solution of a 1% PFAS and I incinerated that, and I incinerated where I destroyed the PFOS in there by 5 nines, that's 99.99% removal. And so I get 0.001% goes out the stack. That stack floats over the lake, and it rains, and it takes that and puts it into the lake. And if this lake is in New York State, the MCL for PFOS is 10 parts per trillion. That 1 liter solution now has the ability to contaminate 10,000 liters of lake water above the standard. So you can see that it does not take very much when we're dealing with part per trillion, and even with removing 5-9 destruction of how much contamination I could cause downwind. And just a side note, I did 5 nines here. Most hazardous waste incinerators are regulated to 4 nines. That's 99.99. So if that's the case, it would be 100,000 liters could be contaminated. So one of the other things was biosolids, and we were trying to not put biosolids in landfills. It had a lot of different nutrients to it, and we started land farming it and putting it on places. And then we started to realize that these wastewater treatment plants were receiving PFAS compounds without even knowing it, and they would drop out with the solids and the bugs in the process. And then we were applying them, and you can see that the median line blue is 13 micrograms per kilogram, right? That's in a part per billion range. And then the green is up to 195, and you can see the difference between wastewater treatment plants that just took basically general wastewater treatment, that's residential and light commercial. And then if you moved into an industrial to the right, you can see how much higher the PFAS concentrations were. And then we started growing crops on them. And this is a chart showing 4 different plants. So radish, celery, tomato, and peas. And they give you the shoot and the root and showing the uptake. And you can see just the difference, if you can, hopefully you can see that well enough, of the difference of where these PFAS compounds can absorb into them and where they end up being held. Some's in the root, some's more in the shoot. But if you'll look at that, there's a big difference in which PFAS compound was actually being able to be uptake. So like the radishes, basically was just doing it for the PFOA. You look at the celery and you have the PFBA, that's a 4-chain or short chain, and it goes all the way up through PFOS with not that much in the PFOA range. And the same thing with tomatoes and peas. So you get uptake of these compounds and in different areas, and whether or not then they become the food supply or not. One of the things I talked about is mentioned was masking the source. So this here shows biosolids. The blue is a sample taken 1 day, right after the biosolids were applied. And the orange is 371 days later. And what you see is a big difference with the precursors. So if you remember, the precursors were the compounds that do not have a fluorine on every carbon. So they're like your telomeres. And you see how they start out and then they degrade and they turn into stable PFAS compounds, which are shown off to the right. And so if I sampled a site and somebody applied on day 1, my result for PFHPA would be basically 0, almost nothing for PFOA or PFHXA. And you go out a year later to sample to see if my results are good, and you're going to get totally different results as shown there. And then down below just shows you how the oxidation for a 8-chain carbon PFAS compound with the telomers can break down into 3 different types of stable PFAS, your PFOA, your PFHPA, or your PFHXA. So that makes it difficult, and finding a source and having that source stay as a source that you recognize based on your analytical. And this is what you see in a wastewater treatment. These are actual results with a telemer 6,2-FTS, where it came in an influent of 1,840 part per trillion, and it left at 105 part per trillion. So we saw a reduction of 1,735 part per trillion for the telemeter 6,2-FTS. That's great. But we see PFHXA actually increase, which is a stable PFAS compound, goes almost 20 to went up to 70. But it's only a difference of 50. So the next question is on a mass balance is where did the rest go? And it's because it breaks down into other compounds or other types of PFAS that we may not be looking for. And it's very difficult to do some of the mass balances. PFAS in landfills is becoming more and more of an issue. So there's 110 landfills in Minnesota, 101 tested, 98 had detections for PFAS, and 58 of those exceeded the drinking water standards for Minnesota. Drinking water facilities will be looking for source of contamination, especially if EPA designates PFAS as a hazardous substance under CERCLA. And if that's the case, then landfills will run an increased risk of being designated Superfund sites. So many states have turned around and started focusing on landfills and closed landfills to start sampling and going back and sampling for PFAS compounds there. And the other thing to recognize is that many times these landfills have PFAS concentrations upwards of 10 times more than what they would normally find coming out of the leachate itself. So what I've seen, biosolids that used to be land applied, going to landfills because of PFAS levels. That is, I mean, we need to do that if we know that they have PFAS in them, but it's just filling up landfill space and wasting what used to be a good biomaterial to be able to reapply and to be able to reuse. State agencies are stepping on the disposal of PFAS contaminated soil, stopping them from going to unlined landfills. There are a number of hazardous landfills that aren't taking PFAS now either. Waste Management has 6 facilities in the New York State area, and they will take PFAS contaminated soil or sediment on a case-by-case basis. So it depends on where it's coming from, how much, what the concentration is, and they do their analysis to try to figure out how it's going to affect their leachate and their permit to be able to discharge PFAS at a certain level to the POTW. Landfills are monitoring leachate compared to the effluent, and they're also looking at the hits in the effluent and asking to test for PFAS at landfill effluent. So there's more scrutiny happening with the landfills. So a recent study, Oklahoma City, 5 water treatment plants, 3 of them receive landfill leachate, 2 of them do not. The worry for disposal of landfill leachate in a municipal sewer. They looked at 72 PFAS compounds, which takes special analysis to be able to do that. And the commercial side does not usually look at that many. PFAS levels in the leachate, as I said earlier, were 10 times higher than those found in the influent effluent. And the PFAS levels in influent were higher in plants receiving leachate, but could not come to a conclusion on the effluent differences that they were finding. So depending on the type of plant and the material going through, would see different effluents, PFAS compounds coming out compared to what was going in. So we need to collect reliable data and the analytical methods. So the very first question, if you're sampling, is what analytes to measure. In New Jersey, we have 3 compounds, PFOS, PFOA, and PFNA. Now, do you only look for those 3, or do you look for the total suite that you would get? depending on who your client is or who you're sampling for, would often require that. I will tell you that I recommend highly, and I'll tell you why in a minute, of doing the entire suite of the PFAS compounds. You need to know what the reporting limits are. Different methods will give you different reporting limits, and so you may not get the results that give you the data that you want. You want to make sure you're doing things like trip blank, which is prepared by the lab, a field blank, which is prepared by you in the field, but using PFAS-free water that came from the laboratory. The equipment blanks collected in the field, again, using PFAS-free water, doing duplicates, MS, MSDs, and report types. There's basically 4 types right now of analytical methods: the 537, 537.1, the EPA 533, EPA 8327, and the DoD isotope dilution method. It is important to know that 537.1 and 533 are drinking water standards. And so they're made specifically for drinking water. So when we're doing them for groundwater, sediment, soils, and everything else, each lab has to make their own standard operating procedure for that gets approved by the state. And so everybody's then procedure for anything other than drinking water is laboratory specific. Makes it then, can you compare one lab's results to another? Also, the reason why they're drinking water is the matrices are very difficult to deal with. And so the more other stuff you have in the sample, the harder it is to get reliable data. 8327 is a fairly new method that came out. It is basically what lab people call a dilute and shoot. It does not have good accuracy. It has high reporting limit. The one thing good about it is it tells you, do you have PFAS or do you not have it? And labs are starting to get approved for it, but it's certainly a questionable analysis. The most reliable analysis is analysis using an isotope dilution. An isotope dilution means that they're spiking your sample with a known PFAS, a matter of fact, usually a number of PFAS. And the difference is that PFAS has a extra carbon to it, or neutron. It has an extra neutron to it. So it has a different weight, but it has all the same properties as the other PFAS. And then when they put that in and they then analyze, they are able to then adjust the result to the exact percentage of recovery they got from the isotope. So for anything doing in a part per trillion range, we highly recommend using an isotope dilution process. Another process, and this talks about how we saw contaminants that would change from a telomer or a precursor to a stable PFAS compound. And in this process, we try to mimic what happens in the environment. And we take a sample, we analyze it the way we normally would for the things, and then we take half of the sample that we didn't analyze and we oxidize it. And when we do that, we try to drive all of those telomers and things to stable PFAS compounds. And then we look at the difference. And that difference then tells us what the presumed precursors are in the PFAS analysis. And that then helps us in trying to figure out, are we in a source area? Has the contaminant changed? What maybe was the real makeup of the contaminant source that was discharged? Everything that we do, before I take a sample, I always try to figure out and say, what am I going to do with the result? And how am I going to justify the results? And as I talked about, the samples, the analyticals that we are using, we're being made to use analytical standards that are for drinking water, but applying them in different matrices. As I said, changing laboratories. or changing analytical makes it difficult to be able to compare one analysis to another. So how defensible is the data that you're getting? You want to get and look at whether the lab reported branch PFAS or not. The isotope dilution standards only come in linear. So if you have a sample that is 50% linear and 50% branch, but you're using an isotope standard that is 100% linear, you know you already have some bias that the lab technician needs to evaluate in deciding what the actual result they want to report is. So there's no standards for many of the PFAS compounds or the media, and there are no standards for the precursors that we've been trying to figure out, are they there and changing into stable PFAS compounds. Why did I tell you earlier to do the full suite? Here's a sample of 2 different analyses of water. These are actually groundwater samples that we took. And the PFOA, the PFOS, and the PFNA are very close to the same results numerically. But when you look at the total suite of other PFAS compounds, you can see that they are extremely different. And we use this type of analysis to look at and determine, is the PFAS that I'm looking at, is it really the same compound or the same solution that was probably released? So I highly recommend doing the full suite so you can get a better picture of what the full makeup is of the PFAS compounds. So the last part of my talk here, I'm going to close in a minute, is on professional judgment. Right? So for me as an LSRP, I have to decide, I told you I had to evaluate whether to sample. And then I have to evaluate, if I am going to sample, what I'm going to sample and how I'm going to sample and everything else. So it comes down to, if I decide not to sample and somebody comes in after me and samples and finds PFAS, the question is was I wrong or was I negligent? And then who has the most liability? Is it the buyer, the seller, an attorney, an insurance broker, the consultant? It really depends on how you go through. So whenever you're dealing with these projects, you need to be very clear on how you are evaluating and what your process was to come up with the decision to either sample or not to sample, or where to sample and how to do the reporting. So hopefully that was interesting. That covers brownfields, covers PFAS, and covers the liability. So can brownfield and redevelopment and PFAS coexist? They can. You need to determine liability protection mechanisms, who your client is. You need to know your client and the team's expectations. And you have to understand the challenges that we do have, where to investigate, how to produce accurate data that can be reproduced, how to determine cleanup standards, especially when there's cleanup standards aren't established yet. And most importantly, under professional judgment, is your judgment defensible? Have you explained it enough that you can justify what you did, whether you were correct or not correct in the final analysis?